Hello everyone, my name is Andragali, the Bazooka Prophet, and today we'll be working on a very interesting video in chemistry and also in biochemistry, which is talking about the conversion of an aldose into the next lower aldose. And under this heading, we have a sub-heading talking about what we call the Ruff's method, or we can also call it the Ruff's what now degradation. In Ruff's degradation, in summary, it involved the breakdown, or it involved the removal of one carbon from a sugar to give us a lesser sugar. Talking about the conversion of, let's say, an aldopentose to an aldotetrous, or the conversion of an aldohexose to an aldopentose. Now, what are the steps that are involved in Ruff's degradation? Now, in Ruff degradation, three steps are followed. And the step one is that the aldose in question is first oxidized with bromine water to give us what we call an aldonic acid. Secondly, this aldonic acid is then treated with calcium carbonate to give us the calcium salt of the aldonic, of the carboxylic of the acid. And lastly is that this calcium salt of the acid is then oxidized with a reagent called the Fenton's reagent, which is together comprises of hydrogen peroxide and ferric acetate. Some tests will tell you ferric sulfate. Now, when that happens, it will then act on the calcium salt of the acid to give us the next lower aldose. And this is what you can see right here on the board. Talking about the first step, when the aldose is being oxidized with bromine water to give the corresponding aldonic acid. Then the aldonic acid is treated with calcium carbonate to give us the calcium salt of the acid. Then lastly, with the calcium salt of the carboxylic acid that is being treated with a Fenton's reagent, CO2 and H2O are liberated to give the next lower aldose. Now the reaction mechanism is as follows. Very simple. We have, first of all, we want to convert a D-glucose to a D-arabinose. And the step mechanism is as follows. We have the D-glucose now, which is follow this step. So this is what we call a D-glucose. So in the presence of bromine water, it is being oxidized. It oxidizes this functional group to give us the carboxylic acid. So everything else remains the same while we make a move. So this is what we call a D-gluconic acid. A D-gluconic acid. This is the first step. Now the second step is that this D-gluconic acid is then being reacted with calcium carbonate. This is 2 plus, this is 2 minus, to give me this is what you get. This is 2 this is what we call a calcium degluconate. And lastly, with a Fenton's reagent, talking about hydrogen peroxide with a ferric acetate, we get water. CO2 will be liberated from here and water. So what you'll be having, so it means here have already been oxidized to give us the what now? To give us the functional group, which is the aldehyde. I mean, this one is already off, which is the CO2. So you are not having an aldehyde there. So everything remain the same. Everything remain the same. So this is what we call a D-arabinose. A D-arabinose. So 3 steps are involved. This is step 1, this is step 2, and this is step 3. This is the reaction scheme. This is the reaction scheme. Now in our next video, we'll talk more on some basic aspects in chemistry and biochemistry. For now, I remember myself, adrenaline, wishing you guys the best. Happy weekend.